Good afternoon, heat and mass transfer students. So I'm here to discuss to you Unit 9, which is Simultaneous Heat and Mass Transfer Operations. And commonly, this is referred to as psychometry or a gas-liquid contact operations. So psychometry is the subject which deals with the properties of gas-vapor mixture. In this type of operations, the gas is brought into contact with a pure liquid in which the gas is essentially insoluble. So as a consequence, the liquid can evaporate because the temperature of the gas is higher than that of the stream of the liquid. So the liquid can evaporate and the gas becomes saturated with respect to the liquid. Alternatively, by cooling the gas, condensation of the liquid can take place. So air conditioning processes can be determined using psychometric charts, and some they use also the Moliere diagrams. Okay, so one of the most important psychrometric operations is the air-water contact operations. These operations are also referred to as humidification process. So in humidification, we often encounter this in a day-to-day practice that whenever reference is made to psychrometric operations, it is always understood to be a humidification process, unless clarified. If it is the other way around, it is the dehumidification operations. So we are to tackle in this topic introduction to gas liquid contact operations, the analysis of operations involving humidification, dehumidification operations, and of course your air conditioning or AC operations. So after finishing this module, you should be able to discuss and explain the principles of humidification and dehumidification. You learn how to use this psychrometric chart in getting the properties of the air vapor mixture. We derive the different formulas and mathematical equations for these two processes, the humidification and dehumidification operations. We apply the principles of cooling tower and then solve further problems in air conditioning and cooling tower. Okay? So as an introduction, let's define first what these gas liquid contact operations are. So when we say humidification, it is a process in which the moisture or water vapor or humidity is added to the air without changing its dry bulb temperature. So cooling and humidification process is one of the most commonly used air conditioning applications for the cooling purposes. In this process, so if you have adiabatic humidification, the moisture is added to the air by passing it over the stream or spray of water, which is at temperature lower than the dry bulb temperature of the air. So it's like in humidifications, if you have here a stream of water and then you pass through a gas here. So by heating this water, water is being evaporated and it goes to the stream of gas. Therefore, if this is the original temperature, the final temperature here, the final is lower. Of course, this is lower than the original temperature. So you cool the gas, and since the heat from the gas is transferred to the water, making it to evaporate, you have the initial temperature of your water with its final temperature, TF is greater than the original temperature of water. Okay? So in here, the ordinary air passes over the stream of water. As I've said, the particles of water present within the stream tend to get evaporated, giving up the heat to the stream. So the evaporated water is absorbed by the air, therefore, nag-increase yung moisture. So you get to, it tends to increase the moisture, or you humidify the air. So that's why its moisture content would increase, humidity also increases. At the same time, the temperature of the absorbed moisture is less than the dry bulb temperature of the air. Therefore, there is a reduction in the overall temperature. That's why I've said the temperature final is less than the original temperature of the gas stream. And for the water itself, since the heat is released into the stream or spray of water, its temperature will increase. Now, dehumidification, on the other hand, is a process in which the moisture or water vapor or the humidity is removed from the air, keeping its dry bulb temperature constant. So it's just the opposite of adiabatic uh, humidification. So for cooling towers, of course, from the term itself, it is used to cool water. We will be tackling problems later on these three gas liquid contact operations. Okay, so let's define first the basic terminology to be used in this module. We have, for the first, is dry bulb temperature. When we say dry bulb, it is the actual temperature of the air vapor mixture. Absolute humidity is the weight of water to dry air. So that's why its unit would always be kilogram of water per kilogram air. So it is actually the amount of water contained in 1 kilogram of dry air. So usually H is given by the formula. You have pressure of air over pressure of B. This is actually in kilogram mole water per kilogram mole air times, of course, the molecular weight. We have 18 kilograms of water per kilomole of air, and for 18 kilogram kilomoles of water per kilomole of water. And for air is the same. You have 29 kilogram of air per kilomole of air. That's why the formula here is, take note, PA is the partial pressure of water, PB is your partial pressure of dry air. That's why you have the formula H is equal to 18 over 29 PA over PB. Note that PB could also be the total pressure minus PA. That's why it's sometimes 18 over 29 PA over the total pressure minus PA. Okay. Saturation humidity is the absolute humidity of the saturated air, or it's the maximum water that air can hold at a given temperature. So this one is, take note that your PA here is equivalent to your vapor pressure of air at this point. That's why you have your HS is equivalent to 18 over 29, same as your H, but this time this is PA naught over P minus PA naught, or the vapor pressure of your water. Percent humidity is actually your ratio of your absolute humidity over saturation humidity times 100. So that is actually H over HS times 100. Okay, or as stated in your module, it's HP is PA over PA naught times 100, P minus PA, not over P over PA. Relative humidity naman, it's the amount of saturation of air-water vapor mixture, or that is H of R is your P over PA naught times 100. So that's your relative humidity. And since you know that your HP kanina, your percent humidity is equivalent to your HR times P over PA naught. Okay? Dew point. It's a temperature at which a given mixture of air and water vapor would be saturated. It is actually the temperature at which your sorry for that. It is your, the temperature, your dew point is the temperature at which your H is equal to your HS, or your absolute humidity is equivalent to your saturation humidity. Humid heat of an air vapor mixture, or we term that as your CS, it is the amount of heat in either joules or kilojoules required to raise the temperature of 1 kilogram of dry air plus water vapor present in 1 Kelvin or 1 degree Celsius. But this specific heat is of course based on specific heat of air per weight of dry air. And in SI unit, we have CS is equivalent to 1.005 plus 1.88 times your humidity, or in English unit, it is equivalent to 0.24 plus 0.45 H. Okay? Now, we go to humid volume. Humid volume is the total volume in cubic meter of a 1 kilogram dry air plus vapor it contains at 1 atm absolute pressure and at a given gas temperature, which is based on weight of dry air. So you have an equation given in your module, that's equation 9.6. Number 9 is your total enthalpy. Some uses I, sometimes ito yung maliit na H. Okay? It's a total enthalpy of 1 kilogram of air plus its water vapor. It is actually, take note, is a combined your sensible heat and latent heat. So you are given equation 9.9 and 9.10 for the reference temperature at 32 degrees. Okay? Number 10 is your temperature attained by unsaturated air if it is made saturated by water spraying under adiabatic condition, or we call that as your adiabatic saturation temperature. In your, I think in your module, I've given you a figure of an adiabatic spray dryer, and then we derive the equation for that given in equation 9.11. Lastly is your wet bulb temperature. It is the steady state temperature attained by a small mass of liquid exposed in a continuous stream of gas under adiabatic conditions. And you are given the equation 9.12, wherein 9.13 is based on Lewis relation of your air-water system. Okay, anyway, all the equations for these 11 terminologies are given already in your handouts, your module. Okay, let's go study psychometric chart. I think this is figure 12-2 in the handbook, page 12-4. So take note, this can be found, but of course this is 6th edition. Figure 12-2, page 12-4 of your handbook. Okay. Let's study psychometric chart. Of course, sometimes it tends to be equations relative to this involving specific humidity, temperature, whether it's wet or dry bulb, the pressure, air or vapor, and enthalpy are quite tedious and inconvenient. So for this reason, we have here a psychometric chart relating all the relevant variables, and which was developed with an extremely useful for designing and evaluating air conditioning and cooling tower systems. Okay, let's study the psychometric chart. Okay. This temperature here is your dry bulb temperature. I think it is given in degrees Fahrenheit, but some psychometric chart are also in degrees Celsius, only in SI unit. Okay. The one on this side is your grams of moisture per pound of dry air, or we call it's the ratio or humidity ratio. It's the amount of moisture per pound or amount of dry air. Okay. This line here is your relative humidity. I have 10%, 20%, 30, 40, up to 100%, noting this line. This is the 100% relative humidity. Okay? Although, also in here, the 80, 75, 70, the numbers here indicates your wet bulb temperature. Okay? So, say, assuming if this is the wet bulb, and the lines, the small lines here, is your enthalpy. Take note, this one. It's your enthalpy. And then the specific volume are this line. So I have, this one is 13.5 cubic feet, this is 14.0 cubic feet, 14.5, 13, and 12.5. So if we try to analyze that one, you have here, so isa-isahin natin. This is your dry bulb temperature. Okay, so dry bulb temperature. This is your humidity ratio. Okay. The lines, the curved lines inside is your relative humidity. So this is your percent RH, or sometimes H sub R. Okay? Now, if I choose this point, assuming ito yung point na gusto ko, if I draw a vertical line, I get its dry bulb temperature. If I do the the horizontal line here, I get the relative percent humidity ratio, or this is the amount of moisture per kilogram dry air. So ito si relative humidity. Now, if I get the line perpendicular to that and extend, diba? You have here the wet bulb. So this is your enthalpy, yung line na nandito. So this is your enthalpy. Enthalpy. Okay? The dew point temperature is if I project that point to the left, horizontal, I get the dew point temperature. Dew point temperature. Okay? And the specific volume is the one, yung pag-ganun naman yung line niya. So this is your specific volume. Okay? So for example, if I would choose 75 degrees Fahrenheit dry bulb temperature and at 60 relative humidity, I could get that point. So 75 dry bulb and 60% relative humidity. That's the point here. If I project it to this side, I will get its humidity ratio, or the amount of moisture per kilogram dry air. Now, getting this one, if I would want to get its dew point, ito yung dew point niya. It's around at 60. Now, getting the enthalpy, so this line, ito yung enthalpy, it's around 30 BTU per pound dry air. Okay? So, what else? The wet bulb temperature is at 65. Okay? Dew point is 60, wet bulb temperature is at 65. Now, specific volume. It is in between 13.5 and 14. So, actually, medyo konti siguro. That's around, ba? This one is your specific volume, or your VH. Okay? So, that's how actually easy once you get to know how to get the different values for your air-water vapor mixture. Take note that these relative humidity lines here, the RH line is not 190, 80, 70, 60, the 50, all of this. Ito yung mga lines na to. This is your relative humidity. These curves extending from the lower left to the upper right, diba? Lower left to the upper right of the psychometric chart. At different curves of your RH, it indicates the different values of humidity measured in percentage. Take note that the value of your RH reduces from left towards the right. So the extreme left curve along the shoe indicates the 100%. Ito yon. So as you move to the right, decreasing. Okay? So, nagde-decrease yung percent relative humidity niya. Okay? And then, this is also called, it's the saturation curve. Itong actually yung wet bulb natin. Which is, at this point, the condition of air along this line is fully saturated no matter what the dry bulb and the wet bulb temperature. So, parang pagdating ko dito sa line na to, I would understand it's 100% humidity or relative humidity. So, it doesn't matter whatever is the amount of your dry bulb and your wet bulb temperature. So, along the saturation curve, all the three temperatures, the dry bulb, the wet bulb, and the dew point is equal. Say for example, at this point, I know that the wet bulb is 50, the dew point is also 50, and the dry bulb is also 50. Okay? Enthalpy, if we talk about the enthalpy, it is the enthalpy that comprises the total enthalpy of the air comprises of the sensible heat and the latent heat. So, this enthalpy scale is in the psychometric chart. Ito, yung mga yan. As I've explained a while back. So, the value of the enthalpy of any given air, one should know, of course, ang isa is you have to know the wet bulb temperature. The constant enthalpy line passing through the given value of the wet bulb indicates the enthalpy of the air. Sabi natin kanina, if I'm to get the enthalpy at 75 degrees F, 60% relative humidity, I just project it here and get 30 BTU per pound dry air. Yung specific volume, ito yung kanina. It is the line that is given by this. Okay? So, specific volume is an important parameter also, since one has to consider the amount of air to be handled by the cooling coil or either cooling fan, and accordingly the rating of cooling coil and fan has to be found out. So, from the psychometric chart, we find out that the specific volume of the required air and find the total volume of the required air by multiplying it with the total weight of the air required. Kasi ang specific volume natin, its unit is actually given as cubic feet. So, 13.0, ito, 13.5. So, if you just multiply that with the total weight of the air required, you will get actually the total volume of the air. Okay, so this is constant specific line. Start from the saturation curve, drop down. Ito, nag-start dito sa saturation curve, drop down. Okay, with a slight angle. So, medyo naka-angular lines yung vertical line siya. It indicates either cubic feet per pound. Okay, so if any of the two values, either your dry bulb, your wet bulb, or your dew point and the relative humidity are known, all other values can easily be found by the from your psychometric chart without having to carry out any calculations. So, without actually solving for it, you could actually play around the different values needed for the air-water vapor mixture. Okay? So, you try to practice reading psychometric chart. Okay? So, let's have this problem. Assume that the outside air temperature is 32 degrees with a relative humidity of 60%. We use the psychometric chart. I think the psychometric chart that I've given you here is already in temperature, which is in degrees, and so SI yung unit niya. So, we use the psychometric chart to determine the specific humidity, your H, your enthalpy, the wet bulb temperature, the dew point, and the specific volume of the dry air. So, let's indicate all the values determined on the chart. Okay, first, you are given at 32 degrees. So, anong muna natin gawin? I have here, assuming this is my 32 degrees, and the 60%. Where is the 60%? So, along this line. So, I project, sorry for that. So, we project at 32 degrees going up until we reach the 60 degrees relative humidity. I cannot draw a perfect straight line. Okay, assuming it is here. Now, if we project it after the humidity ratio, so you get a value here. So if this is 15, siguro this is around 18. So your specific humidity, your H, is 18 grams per kilogram of dry air. Okay? Next, what is the enthalpy? The enthalpy is around, kung ito yung enthalpy niya, wet bulb, and enthalpy of the dry air. So if I am to project it here, so pag ganun yung the enthalpy here, yung line. So kung ito ay 75, 57, teka lang. Assuming I have here, sana yung super straight. So if I am to project, eto yan. Sorry ha, hindi masyadong magandang line. Okay. To get my enthalpy, this is around 75 kilograms. Kung maganda lang yung lines natin. Okay. Assuming na ito yan. So I have here line 32. Wait. Gandahan natin yung lines niya. Okay. Let's do it again. At mas manipis. Okay. So, this is around 32. Project it. Assuming na maganda yung pagkaka-project natin. If I am to project it up to the 60. Oh, I'm sorry. So, kapag kayan, kung mas manipis, the better. So, kung titingnan natin, so this is around 18 yung humidity. Actually, the point. So, since this is the enthalpy is around 75, so lagpas ng konti ng 75, so 76 or 77 yung line. This line here is your H, your enthalpy, or around 77 or 78 kilojoules per kilogram. Now, if I want to get the wet bulb temperature, the wet bulb temperature is the line here. So, if this is 25, so lagpas ng konti rin ang 25. So, assuming this is 30, so kung ito yung 26, wet bulb temperature is around 25.5. Okay, degrees Celsius. Now, projecting it horizontally, I would get the dew point. So, ito yung dew point. Dew point is at this point here, or that's around 20. This is 25. This is siguro mga 23 degrees Celsius. Okay, and the specific volume. If you get to have the specific volume, take note, it's the green line here. So, titingnan ko to if I am to project green line. So, ito. I would have, sige, i-green line din natin. This is the line for the specific volume at this point. So, I get around a value of 0.87, mga 0.89. So, the specific volume here is around 0.89 cubic meter per kilogram. Okay? So, that's how easy it is. So, you have just knowing to either relative humidity and the dry bulb temperature, you could actually get so much of the properties of the air-water vapor mixture. Okay? Now, let's do number 2. Assume that the outside air temperature is at 8 degrees Celsius. If the air in the room is 25 with a relative humidity of 40, we use the psychometric chart to determine if we have here if the windows of that room which are in contact with the outside wall will become foggy. So what is given for us here is, can I erase the first? Para hindi tayo malito. Okay. So you are given 40 degrees relative humidity, 25 degrees room temperature, and the outside air is given at 8 degrees centigrade. We are to determine, will it become foggy outside, yung outside wall ng window. Okay? So you are given 25 degrees, project it to 40 degrees relative humidity. So it is at this point. Parang gusto kong blue. Okay, we try the yellow one. Okay, so at 25 degrees, project it up to 40. So this is at this point. Okay. And then, if I am to project, get the dew point, knowing that the outside air, take note the outside air is 8 degrees. So kung titingnan ko yung 8 degrees, if I project it here, andi dito si 8 degrees. 8 degrees centigrade. Okay. So if I am to project this one, 25 degrees at, kulang, 40. Sorry for that. Ang pangit ang yellow. Pasensya na. I-heavy na natin ng red. Okay. So, 25 degrees projected up to 40. So, ito yung 40. At this point. 8 degrees centigrade yung outside temperature. We are to determine if there's fog. If I am to project this one, you would notice that the temperature is slightly higher than 10 degrees. So at that point, the water vapor condenses up to the time that it will reach the 8 degrees Celsius. So it will condense because the outside air is given at 8 degrees. So slightly 10 degrees higher, magko-condense siya. Therefore, as it approaches 8 degrees along this saturation line here, the 100% relative humidity, the window will become foggy. Okay? Kasi nga, di ba, mas mababa yung temperature outside than the temperature given in the room temperature, which is 40 degrees Celsius and 25 40% relative humidity and 25 degrees centigrade. Okay? Now, one major application of the psychometric chart is air conditioning. And we find that most humans feel, of course, we feel comfortable when the temperature is between, actually, is between 22 degrees and 27 degrees centigrade, and the relative humidity between the 40 and the 60. This defines actually the comfort zone, which is portrayed on the psychometric chart. So let's find that one. If our comfort zone is between 22 degrees and 27 degrees centigrade, where is that? So if it is between 22, and 27 degrees centigrade, so this is along this line. So 22 degrees and 27 degrees centigrade, and a relative humidity between 40% and 60%. So if I am to project that, we'll get it here. So where's the 40? So project the 22. Should make this straight line, sorry for that. And the 20. So we find, therefore, that our comfort zone is just between this area. So it is between 22 degrees and 27 degrees centigrade, and the relative humidity between 40 and 60 degrees centigrade. Okay? So, assuming now that the outside air is 35 and 60% relative humidity, it is to be conditioned by cooling and heating so as to bring the air within the comfort zone. You use the psychometric chart to plot the required air conditioning process and estimate first the amount of moisture removed, the heat removed, and the amount of heat added. So parang you are given outside air is 35, relative humidity is 60%. What can we do for you to be able to go back to your comfort zone, knowing that your comfort zone must be in between 22 and 27 degrees and a relative humidity of just around 40 to 60. Okay? So we plot what's given. So kung ito yung comfort zone natin, the one that is given is I have a 35% and 60% relative humidity. So it is this line. Okay? So for me to be able to go back to this comfort zone, say my target is to arrive at the 24 degrees centigrade. Assuming yun ang gusto ko, sa 24 degrees centigrade. Sorry for that. Okay? So your target is to go back within this comfort zone at 24 degrees centigrade. So what you can do is, first you need to remove, sabi natin, we are to get the moisture removed, the heat removed, and the amount of heat added. Why? Because you have here, for me to be able to get back to this zone here, so kung ipo-project ko, ayan, for me to be able to get to this point is that I need to lower the saturation, the relative humidity, of course. Kasi although nasa 60, so nasa boundary ka, and your aim is to go to this point at 24 degrees. So this is point 1, you project it to your 100% saturation. Then if I am to project this, so ito yung point 2 ko, this is your point 2, and then this is your point 3 here. Okay. The difference between this point and this point is actually your moisture removal. Itong length na to. This is actually your moisture removal. And how are you going to get that one? It is, if I am to read the percent moisture removed, that's around, this is 22, around this is 10.5. So the amount of moisture removed, yung moisture removal na to, is I have 22 kilogram of water per kilogram dry air minus 10.5. So you get the difference is around 11.5 grams of water per kilogram dry air. Okay? Now, we are to get how much is the heat removed. For you to get the amount of heat removed, you have here, so heat removed, it's cooling, right? So if I am to project etong area na to, for the enthalpy, that's kilojoules per kilogram of dry air, and this one, at this point, so kung halos nasa, sige, assuming nandun tayo sa very near, actually, very near your 40 degrees. O kaya, kung mga 40, 41, yung area na yan. So, this is the amount of heat removed or cooling. Q, cooling, di ba? Amount of heat removed, also this area. So, in letter B, if I get the heat removed, or Q cooling, that is around siguro 88 minus 41. Okay, or you get that as 47 kilojoules per kilogram dry air. Now, we're tasked to get the amount of heat added because you went back to 15 degrees or around. That's actually here. So, 15 degrees centigrade, papunta ka ng 24. So, if I'm to get the 1, the Q heat is this area naman. Etong 50 na tumama doon minus the heat here, yung 41. Ito naman na yung heat added or Q heating. So, letter C, your Q heating is yung point na to, it's 50 minus 41. So, you get as 9 kilojoules per kilogram dry air. Okay? So, you take note of the procedure that you've undergone. So, from your 35 degrees centigrade outside, 60% relative humidity, for you to be able to go to your comfort zone at around 24 degrees in between your 40%, 60% relative humidity, the first is you must remove, for you to be able to get to this, you remove first moisture. Moisture removal, then you go cooling, and then heating. So, those are the three procedure. Okay? So, gamay nyo na yung psychometric chart. Another. This one is using again the figure in the handbook. We're tasked to get the H and TS given that I have a 70 degrees Fahrenheit dry bulb and 30% relative humidity. So, again, from your 70 degrees Fahrenheit and relative humidity of 70, so ito yung dry bulb temperature, project it up to the 70%. So, ito yan. For me to get your H, ito lang siya. Okay? So, that's around 0.011. So, for letter A, this is your H. So, H for letter A. For letter A, H is at 0.011 pound of water per pound dry air. And what's the saturation temperature? The saturation temperature is at this point. Ito, pag pinroject ko doon, this is 60, 61, 62. Kung pinroject ko siya, at around 63 degrees Fahrenheit. Temperature, 63 degrees Fahrenheit. Okay? That easy, right? Okay. Letter B. You're given 125 degrees Fahrenheit and a saturation temperature of 92 degrees F. So, 125 degrees Fahrenheit. Okay, medyo kulang. So, default natin si number 2 kasi ito yung parang lower temperature. There's another psychometric chart having a higher temperature. Yeah, so, kung ito, assuming ito yung 110, so the usual lang is you get your 125, the saturation temperature, this is 80, so 90 at 95. Pag kinuha mo yun, dalawa, just project it to the other side. So, you get your H. Okay? For this is actually letter C. Sorry for that. Letter C. You're given 40 degrees dry bulb, and the saturation temperature is equivalent to your wet bulb. So if it is saturation temperature is given to the wet bulb, your H is equal to HS at 40 degrees Fahrenheit. So where is that 40? Yun. So this is the 40. If you project it, you get your HS at this point, or 0.005 bago mag 0.6. So assuming yan, magaling yung mata natin. So for letter C, your H is 0.005. Anong gusto nyo? 2 or 1. So it's just really just below 0.006. Okay, so we go analysis of operations. First is for adiabatic humidification. We have two types, the pack tower and the spray chamber. So for adiabatic humidifications, the process in here is the moisture or water vapor or humidity is added to the air. So, diba, we know already from very first discussion that for adiabatic humidification, the transfer of the material, yung mass, yeah, take note, this is simultaneous heat and mass transfer. So if we talk about adiabatic humidification, first, the transfer of material is from liquid to gas. Tama? Mag-evaporate si water going to the gaseous state. And the transfer of heat naman, the one that makes the water evaporate, you transfer the heat from the gas to the liquid. Okay? So this is adiabatic humidification. It can either be using a pack tower or spray chamber. In your handouts, I have given all the equations needed, whether it's water balance, the mass transfer equation, heat transfer equation, and the enthalpy balance is given there already. Anyway, we will be using that in the problems that we'll be discussing. Although I think this one may mga problems akong sinama dun sa handouts ninyo, which is laid down to you already. Okay? So in dehumidification process, wait, I just want to just take note of discuss dun sa if we apply adiabatic humidification to the psychometric chart. So, di ba, ang psychometric chart natin looks like this. So, humidity ratio, dry bulb temperature, this is your wet bulb temperature, this is your humidity. Okay? So, this wet bulb increases going to the right, increases upward, and also this one. Even the enthalpy. Take note of the enthalpy. It increases. So, ito yung enthalpy natin. So, for humidification process, say, assuming you are given dry bulb temperature or your dry bulb temperature at 1 and meron kang relative humidity 1, RH1. In humidification process, you want to increase the moisture. Therefore, by cooling and humidification to, if you want to increase the moisture of the water vapor, you must increase its relative humidity. So parang if this is the other one, ito yung mas mataas na relative humidity, all you need to do is project this, point up to this, yung target mo na relative humidity na bago, or RH2. So you get, if I project this point, this becomes my DB2 or dry bulb temperature 2, and dew point 2 naman na ito kasi this is my dew point 1. Take note. Dew point 1. Kung kukunin ko to, this is my dew point. So for that, tanggalin ko muna itong wet bulb. So projecting that, I have dew point 2. Okay? So yung enthalpy naman, the enthalpy that is being projected. This is your enthalpy 2, your H2. Yung H1 ko is this. Kung naka-project, H sub 1. So, parang in adiabatic humidification, increase of relative or moisture content. So, from this point, project mo lang hanggang dun sa gusto mong relative humidity 2, then you get all the other properties already. Okay? So, these are the governing equations for both the spray chamber and the pack tower. So, in dehumidification, given din yung mga equations na natin. So, this process is represented by the straight vertical line on the psychometric chart. So, kung ito again yung psychometric chart ko, you have here, kung given ka ng dry bulb, temperature 1, so this is my point 1 here. All you need to do is make a, so cooling and dehumidification to. You have here the enthalpy ulit, kung naka-project doon, this is your enthalpy 1. All you need to do for cooling is project here up to a saturation temperature at this point. So this becomes my dry bulb 2, and this is your wet bulb 2 and your dew point 2. Take note that at percent saturation, your dry bulb, your dew point, and your wet bulb is equal, or they are the same. Ito yung dew point 1 mo naman. Okay? And of course, you know that this would be the enthalpy 2. Again, I'd like to reiterate that at 100% saturation, the wet bulb temperature, the dew point, and the dry bulb are all the same. Okay, so you have here the governing equation for the humidification, and last is for your cooling tower. Anyway, this is already laid down in your handbook. So let's just proceed to solving problems. The one that I included in this video lecture is different from the sample problem that I gave in your handouts. Anyway, yung nasa handouts nyo, lahat ng steps niya laid down. Okay? So, I'd like to make another, to solve a new problem in this video lecture. Okay? So, these are more on application. Let's have problem number 1. Air at 75 degrees and 60% saturated is to apply to a room every 8 minutes. The room has an inside dimension of 25 feet by 25 by 20. The air will be preheated from an ambient temperature of 65 degrees. You calculate the heat load in the heater in BTU per hour. Okay. Let's do the diagram first. So I have here a room that measures 25 feet by 25 by 20 feet. Okay, so it is being supplied with air that is being preheated. So this is my preheater. Or my heater na lang. Sige. We call that as your heater. Preheated na siya. Sorry. So this is my heater. And the temperature of the ambient is at 65 degrees centigrade. It becomes, so since it is heated, the one that is being supplied to the room is at 75 degrees C and 60% relative humidity. And this is supplied every 8 minutes. It has to get the heat load in the heater. Okay? So, let's get first properties of air at 75 degrees Fahrenheit. So, at 75 degrees Fahrenheit, what is the saturation humidity? I did I include, so I think I need to make use of this. So you are given 75 degrees, 60% relative humidity. So where's my 60% relative humidity and 75 degrees? So I'll just project it up to this point. Tama? This is 75. This is 60% relative humidity. If I want to get the saturation is around ito. It's so near this point. So, tama ba? 50, this is 60, 75 degrees F. Okay, if you are to project it here, ito yun. So, it's between 0, 1, 1 and 0, 1, 2. So, since medyo mataas-taas na, 0, 1, 5, so 0, you can have it at H is at 0.0115. Okay, so we go back. So if at 75 degrees, your HS is 0.0115. That's the BTU. Sorry. BTU per pound dry air. Sorry. And since you have here 60%, yung H ko na makukuha would then be 60%. So 0.60 of your 0.0115. Now, using equation 9.5, which is your CS, what's our equation 9.5 now? We are to get your humid heat. CS is given using equation 9.5, C sub S, or in English it's English unit 0.25 plus 0.45 of your H. So this is at around 0.24, 0.24, sorry for that. This is actually 0.24 plus 0.45 of a 60% of 0.0115. If you get here 0.60 times 0.0115. So that would be your CS. Getting your CS, you could substitute it here to get, getting first your W. W is, I have a 25 by 25 by 20 feet. So I get 25 by 25 by 20 feet. That is being supplied every 8 minutes. So this is in cubic feet per minute. Times, there are 60 minutes per hour, times the specific volume. So you get here per cubic feet per, so 1 over the specific volume. 1 over the specific volume is around 13.7. This is cubic feet. Sorry. 1 over 0.37, this is cubic feet per pound dry air. The 13.7 is actually coming from, again, your specific volume at this point. Ito yan. So, kung ito ay ipoproject ko, this is in between 13.5 and 14. So, ilalagay natin siya at around 13.7. That's actually 13.7 cubic feet. Bakit ko ba nilagyan? Sorry. So, that's 13.7 cubic feet per pound dry air. So, you get your value, cubic feet, minutes. So, pound dry air per hour. So, that's around 6833. Let's check. So, it's 25 by 25 by 20. Right, times 60 divided by 13.7 divided by 8. So, 6843 pound dry air. Please check na lang. Paki-double check na lang if this amount is correct. So, this is pound dry air per hour. So, that's your W. To get that, the Q, I could now have Q is from our formula WCS T2 minus T sub 1. We get first what is the H there, so it's 0.60. The amount of your CS is 0.60 times 0.0115 times 0.45 plus 0.24. So it's 0.243. So using the value 6843, this is pound dry air per hour times your CS, which is 0.243 times 75 minus 65. Okay, so you get 6843 times 0.243 times 10. That is 16628 or 16629. 629. This is BTU per hour. That's your Q. Now, using my enthalpy balance, okay, at temperature T2, which is 75 degrees, I was able to get H. So, T2, which is 75 degrees Fahrenheit. The H that we got a while back is the 60% of 0.6 times 0.0115. 0.0069. Oh, wait. And that is 0.6 times 0.0115. 0069. So your H is 0069. No, that's the 0.60 of this. 00115 ba? Tama. H is 0.0069. And therefore, I would get your enthalpy at this point. So, kung ang H natin here at 0.75, where is that? This is 0.75. Ano yung enthalpy? This portion here. So, nasa 30. Take note. This is the enthalpy at 75 degrees. 30. Now, we need to get also at 65. What's the enthalpy at 65 degrees? So, at 65, ang enthalpy na kukunin natin is, where is the 65 degrees? So, ito yun. So, if I'm to project this, ito yung 65. So, kukunin ko dito. So, that's around 27.5. Okay? So I have, I'm sorry for that. So I have at 65 degrees centigrade T1, your enthalpy, or ang ginagamit natin, enthalpy is I. So dito, I is at 30. Your I at I2, this is I1. Enthalpy I, that's the, I think the one that we're using because some of the books uses a small h. Okay, so for consistency with our module, we use the variable I to indicate your enthalpy. Okay, so I is around 27.5. Therefore, to get the final Q, I have W times I2 minus I1 minus I sub 2. Or that is around 6843. That's pound dry air per hour times 30 minus 27.5. The unit here is, sorry for that, BTU per pound dry air. So if it is BTU per pound dry air, this cancels out. Finally, I have Q in BTU per hour, which is 6843 times 2.5. So that is 17,107.5 BTU per hour, which is the final answer. Okay? Now we proceed with problem number 2, which is, this actually is cooling with condensation, or that's dehumidification. In a plant laboratory having a floor area of 110 meters squared and a ceiling height of 3 meters, the temperature and relative humidity are kept at 23.9 degrees C and 80% respectively. The closed-loop air conditioning unit installed for the purpose has an air handling capacity to change the air in the room, which is 80% void space every 10 minutes. The air leaving the condenser has a temperature of 18 degrees. We calculate the duty of the AC, the air conditioning unit, and the quantity of condensate which has to be drained from the unit in kilogram per hour. Okay, let's draw first the diagrams. I have an air, or sorry for the room, which has an area of 110 meters squared. We have the height of 3 meters. T1 is kept at 23.9 degrees C, 80% relative humidity, and 80% void space. Okay, now an air conditioning unit, okay, assuming this is my AC. So you have here the one incoming to the AC is same, which is 23.9 degrees C, or that's roughly 75.02 degrees Fahrenheit. And 80% relative humidity, RH. Okay. It has to get the Q, the duty of the condenser, and the quantity of the condensate, the L, because this is at point, if this is at point 1, the point 2 that is being supplied in the room by the air conditioning unit would be at 18 point, leaving the condenser is at 18.3 degrees or 18 degrees to 18 degrees C, or roughly at 65 degrees Fahrenheit. So this is my T sub 2. Okay? So in your psychometric chart, let's erase first the solution for problem 1. Okay. So we need to get both the humidity at point 1 and point 2, knowing that I also have again 75 degrees F, but the relative humidity is at 80. So this is the line for 80, this is 75. So andoon siya. Right, this is 75 degrees, 80 percent relative humidity. Okay, so we are tasked to get H and the specific volume. If I'm to get the H and specific volume at 80%, 75 degrees, I'll just project it here. So that's around 0.015 ang H. Ito yung H ko. Specific volume, this is in between 13.5 and 14. So kung ipoproject kong pag ganito siya, parallel to the lines here, these two lines, I get to have at around 13.6. Kasi 14. So kung titingnan mo kung 13.5, so assuming we get that at or 13.7, 13.567, kasi this is 14. Okay, so your specific volume, so we plot at point 1. T1 is 75 degrees Fahrenheit, 80% relative humidity. My H is 0.015. 0.015. That's pound per pound dry air. Okay. Tapos my specific volume, pH, is around 13.7. At point 2, T2 is around 65 degrees Fahrenheit, 80% relative humidity. The H that I would get is, where's the 65, 80? This one. At this point, 80%. If I am to project it here, so that's around 0.0105. So ito yung area. So at point 2, my H is 0.0105. Okay. So the W that I would get for the void space, I have, if I'm to compute, I have 100 meters squared, meter squared area times a height of 3 meters. I have a 0.8 void space. And this is being supplied every 10 minutes. So if I'm to multiply that, 1 over 13.7, the humid volume, that's cubic feet, times, so this is in meters, I need to, so this is per pound dry air. 1 meter is 3.28 feet cube, times, there are 2.2 pound per kilogram. Okay, so I would have there a value of around 28 something, 28.31. Okay, let's check. So I have 100 times 3 times 0.8% divided by 10, so that's 24 divided by 13.7 divided by 2.2 times 3.28 cube. That's around 28.1. So this is 28.09 or 28.1. This is kilogram already, dry air per minute. So I have here per minute. So I get 28.1. Okay. The liquid out, your L, would then be equivalent to your W times the humidity, which is your H1 minus H sub 2. So you get 28. This is the liquid out. Take note. I think liquid out or the condensate. 28 times, this is kilogram, sorry. Kilogram dry air per minute times 60 minutes per hour multiplied by H1 is 0.015 minus what's the H2 kanina? 0.105. 0.105. This is kilogram water per kilogram dry air. So get her air 0.015 minus 0.0105 times 60 times 28.1. So get around 7.6. Your L is around 7.6 kilogram of water per hour. Okay. Last is we need to find Q. To find your Q, we need to get first your enthalpy. I1, note that our formula is I1 minus I sub 2. I1 minus I2. So we need to get the enthalpy at point 1 and enthalpy at point 2. Okay. If you are to get your I1 or enthalpy at point 1, we can take note that we also have in equation 9.10, if you're to use a reference temperature of 32 degrees you're given here, or pwede ko rin naman gamitin at 0 degrees reference temperature para hindi na ako mag-minus ng 32. So if my reference temperature, if I want to use a reference temperature of 0 degrees F, so take note, this is reference temp. Your I is equivalent to your CS times T. So equation 9.10, so that is your CS times T plus 1075.4. Take note that your CS is also equivalent to your, you have here. Okay, knowing your age, diba, that is your CS is 0.24 times 0.45 H, diba? It's given as 0.24 plus 0.45 times yung humidity times the temperature plus 1075.4 times H. Sorry for that, there's an H here. So we know already the temperature T1 is 75 degrees, your H is 0.015, so just plot the values. So that's 0.24 plus 0.45. Your H1 is 0.015. multiplied by T1, which is 75, since 0 na yung pinili nating reference temperature. So that's just 75 degrees F plus 1075.4 times 0.015. So you get the values to be around 34.6. Okay. So 0.015 pa rin naman siya. So that's around 34.63 BTU per pound. Now, if I want to multiply this to get an SI unit, there's 2.326 kilojoules per kilogram per BTU per pound. That's why you get it around 80.56 kilojoules per kilogram. So same is true in getting your I2. To get naman your I2 is the same. You use the formula CST, but this time ang H ko is 0.0105. Tama? 01, ito 01 pala to. 0.0105. Kasi ito si H2 ko at 65. So, you get your I2. Kung 0.0105 siya, makakakuha ka around 27.20 BTU per pound. And roughly equivalent to 63.26 kilojoules per kilogram. Plotting the given, I would have Q to be 28.1 kilogram per minute, kilogram dry air per minute, minus I1, which is 80.56 minus I2, 63.26. This is kilojoules per kilogram dry air, and multiply 1 minute 60 seconds. So I get 8.18 kilojoules per second, or that's 8.18 kilowatt. So this amount of Q, or that's the amount of heat that you are to or the Q, which is the duty of your air conditioning unit in kilowatt. You already get the quantity of the condensate, which is 7.6 kilogram per hour. Okay, so that ends the lecture for the gas liquid contact operations. I hope you're able to follow how to utilize your psychometric chart and then practice it in the given example in your module. So next meeting we'll have, I think, your long quiz. Okay, thank you very much.